How you doing, Freddie? Where are you going? Hey, Jerry, I've been saving for the past few years and now have a wad of cash. I want to invest it so it'll grow into a bigger wad of cash, and I was told that Shady Joe Investments was the place to go. Shady Joe? Why don't you ask our financial maths dude, Finola Finan, to invest it for ye? I dunno, Jerry dude. Finola will just recommend a bank or credit union, and it will take ages to grow there as interest rates are not so good at the moment. Shady Joe is the best. Fair enough, Freddie, but I'm not sure that's the best plan. Hey, Shady Joe, how's things? Things are good, kid. A lot of satisfied customers getting rich. I got 6,000 to invest, Shady. Word on the street is that you're the best. I am indeed, kid. I'll make that money grow faster than the weeds in my garden. Great stuff, Shady. I'm a bit of a maths whiz. Can you tell me how my money will grow? Sure, kid. My own maths guy came up with this formula. Whoa, Shady Joe. That's just a quadratic function, with v, the value of the investment, as a function of time. Not sure about the maths, kid. It's my own maths guy works this one out. Yes, Shady Joe. It's a maximum quadratic function, and c represents the initial value of the function. If I were to graph this function on the x and y axis, then the value of c is where the graph would start on the y-axis, which would be the amount of my investment. 6 big ones. The y-axis we will label v, as v, which is the value of my investment, is the output of the quadratic function. The x-axis we will label t, as time is the input to the quadratic function. So, Shady, you can see that this is a function where for any value of t, the function will calculate the value of the investment. Is t the time in months, Shady? Yeah, kid. You will notice that when no time is elapsed on my investment, that is, when t equals 0, then the value of the investment is 6,000, which of course is my initial investment amount. This is in fact the value of c in the function. Well done, kid. I'm impressed so far. So tell me, Shady, after how much time should my investment be cashed out? What's your recommendation? Well, kid, my maths guy tells me the best time we can cash out your investment is in 4 years' time, and you'll double your money. Okay, Shady, let's use our function to see what happens in 48 months. I will just substitute 48 for t into the quadratic function and calculate v. Your figures stack up, Shady. In 48 months' time, it looks like the 6,000 will double to around 12,000. 12,144 in fact. Just one thing though, Shady my friend. If we look at this graph, you will see it's got a maximum value here. My question is, am I taking my money out at the right time so it is at its maximum value? Yeah, kid. My maths guy tells me you are. Well, this is fairly easy to find out using differential calculus. Differential calculus? Sounds complicated. Not really, Shady. When we put t equal to 48 into the investment function, the function calculated the exact value of the investment after 48 months. So what you're telling me, Shady, is that t equal to 48 is directly underneath the maximum point on the graph. We can check this easily enough using differentiation. Check away, kid. Okay, when we put t equal to 48 into the function gives the actual value of the investment. But when we put t equal to 48 into the derivative of the function, the derivative will tell us whether the value is increasing or decreasing. When the value of the function is at its maximum, the value of the derivative is 0, as at the maximum point of the function is neither increasing nor decreasing. Before we do this, let's just put 512t to 512t to the power of 1, as any number on its own is to the power of 1, and it's easier to see differentiation when all the input terms are to a power. To do differentiation on a simple quadratic function, we simply bring down the power of each input term, in this case any term with a t in it, and multiply the number in front of the t by the power. We then reduce the power of that t term by 1. Finally, we drop the number on its own, that is, the term without the t, in this case 6,000. The derivative is called dv dt, as it is the derivative of v with respect to t. Now we can tidy up our derivative. T to the power of 1 is of course just t, and t to the power of 0 is 1, as any number to the power of 0 is 1. Well, Shady, I've been doing a lot of talking. Are you following me?
Like a moth to a flame, kid.
Very funny, Shady. You're some comedian for sure. Okay, back to work on our derivative. Now, let's substitute 48 for t into the derivative and see what the diddly-dory is. Well, Shady, we seem to have a bit of a problemino here. Although we calculated the value of the investment after 48 months as €12,144 by substituting 48 in for t into the quadratic function, when we substituted 48 in for t into the derivative, we got minus 256. Because the value of the derivative when t equals 48 is negative, this means that after 48 months, the value of the investment is decreasing by €256 per month. As the value of our derivative is negative, the investment is decreasing after 48 months, which means we are on the downslope of the graph after the maximum point. If the value of our derivative was positive, the investment would be increasing and we would be on the upslope of the graph before the maximum point. Now here's the trick, Shady. At the maximum point, which is the maximum value of the investment, the value of the derivative is 0. At the maximum point, the value of any mathematical function is neither increasing nor decreasing. It's what we call stationary. We can easily calculate how many months it will take for our investment to reach its maximum by simply finding the value of t when the derivative is 0. We are going to have to do a little bit of algebra here, Shady. How's your algebra?
You're pulling my leg, kid. I can't even spell algebra.
A, L, G, E, B, R, A.
Just joking with you, kid. I can spell algebra, I just can't do it.
Okay, so we let our derivative equal to 0. What we are trying to do is to get t on its own by manipulating the equation. Let's subtract 512 from both sides. Now, let's divide both sides by minus 16. Now we are left with t equals 32. That wasn't too difficult, was it, Shady?
Whatever you say, Einstein.
Joking again, Shady. Maybe you should get into comedy full-time.
Yeah, kid. I could call it Shady stand-up.
Nice one, Shady. But don't give up the day job just yet. Okay, back to business. So after 32 months, the value of our investment will be at its maximum. Let's find out what that maximum value is by substituting t equal to 32 into the quadratic function. Well then, Shady, this calculation is telling me that at the end of 32 months, my investment is worth 14,192 big ones.
Very impressive, kid. So, are you gonna invest your $6,000 then?
I don't think so, Shady. I don't trust your maths guy, or maybe somebody else is trying to fool me. Was that your plan? Cashing out my money after 32 months at the maximum value, then giving me only double my money after 48 months and pocketing the difference?
Ah, kid, I wouldn't do that. You can trust old Shady Joe. Bet your life on that.
To be honest, Shady, I wouldn't trust you as far as I could throw you. I'm going to contact Fanula Finan, the finance maths dude.
That heights, kid. That really heights.
Hey again, everyone. Thanks for taking the time to watch the video. We'd really appreciate a thumbs up. You can also help our mission to provide high-quality conceptual maths learning videos by completing a very simple and anonymous online survey. It won't take you longer than 3 to 5 minutes. You can scan the QR code or use the survey link in the comments. Thanks again and have another great maths day.